Olá, meus amigos e minhas amigas, sejam muito bem-vindos a mais uma aula do nosso curso Desmonte Subterrâneo. Só que, antes de começarmos essa aula, eu quero apresentar para vocês o que o canal Mineração de Cabo a Rabo vai estar trazendo este ano para toda a comunidade técnica do Brasil. Nós teremos a segunda edição do ETECMIN, ou seja, o segundo encontro de técnicos em mineração. É um evento gratuito, teremos mais de 40 palestrantes, teremos empresas expondo seus equipamentos, sua tecnologia, seu material, enfim, vem muita coisa boa por aí, muita coisa boa mesmo. Então, se você quiser saber mais detalhes, eu vou deixar aqui embaixo, o link para você se inscrever, como está aí na imagem. É grátis e, com isso, você vai deixar seu nome e e-mail e vai ser informado sobre toda a programação do evento e como ela se realizará. Não se preocupe, você não vai pagar nada por isso. Mais de 40 palestrantes. Isso aí, meu amigo, é coisa de outro mundo. Tá? Canal Mineração de Cabo a Rabo busca trazer conhecimento com qualidade. E vocês vão ver isso no ETECMIN, Encontro Técnico de Mineração. E deixa de blá 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 e vamos em frente, porque tem muita coisa por aí. Vamos lá, meus amigos, a hora é essa.
Cut and fill mining is a favored choice for steeply dipping and sometimes irregular ore bodies, and preferred by mines that require the capability of selective mining and adaptability to variations in the rock mass. It is generally referred to as a small-scale mining method. Mining is carried out in horizontal slices along the ore body, where the bottom slice is mined first. The excavated area is then backfilled and production continues upwards. Each production level is accomplished by drifting until the entire slice has been mined. The slice is then backfilled and the fill becomes the working platform from which the next level is mined. Backslashing is done for providing access to the upper slices within the stope. When a stope is completed, a new access drift from the ramp is created to continue the production within the upper stope. One of the advantages with cut and fill mining is the possibility to reuse waste for backfill material, such as tailings sand from the processing plant or waste rock from development. To mine the ore in one of the slices, we first need to drill blast holes. The next steps are charging and blasting the ore, and then ventilate the toxic blast fumes. The ore is then mucked out and dumped into an ore pass or onto a truck. Before continuing with the next round, the rock needs to be reinforced. How this is done is decided by the mine for each individual situation. The mining continues until the entire slice of the ore has been mined. Since the mining can be tailored to suit the shape of the ore body, it is possible to minimize dilution of waste rock. To get access to more production points, a second entrance can be opened at another level in the ore body and excavated in parallel. The equipment used for mining the ore is usually the same as what is used for development. As the ore body is mined, the rock stresses increase in the pillar above the mined area. Cut and fill mining is regarded as a low productivity mining method, but the advantage is high selectivity with good ore recovery and low dilution. Block caving is a large-scale mining method that allows for huge volumes of rock to be extracted efficiently. However, the development time before production starts is longer compared to other mining methods. By drawing rock from the extraction level in the lower part of the mine, a gap is created. Absence of support for the overlying rock mass, together with rock stress and gravity, will cause the rock mass to cave. This minimizes drilling and blasting of ore, but requires the ore body to be large enough and the rock conditions to be favorable for natural breakage. To draw the first pieces of rock, to create this gap, the rock mass in the lower part of the ore body needs to be broken down into smaller pieces. To achieve this, an undercut level is developed and blasted. Below, an extraction level is developed where ore will be extracted throughout the life of that production area. Drawbells are created between undercut and extraction levels and become passages for caved rock. To avoid misfires, accurate drilling is crucial. Substantial rock reinforcement, such as steel arches, sprayed concrete, cable bolts, rock bolts, steel mesh, and straps, are usually required due to several factors associated with block caving, including extreme rock stress changes and a long production period. Rock is loaded from the draw points and can be dumped into ore passes connected to a haulage level or directly into a crusher. A variety of transportation methods can be employed for transporting ore to surface. The fragmentation of the ore and the crushing requirements are key factors influencing the choice of a method. The extraction of ore will sooner or later cause the surrounding rock to cave, resulting in subsidence on the surface. Provided the rock breaks successfully and the ore can be extracted evenly at desired draw points, block caving is a high productivity method with low operating cost that allows a high degree of mechanization and capability of automation. Sublevel caving is a large-scale mining method suitable for large ore bodies with a steep dip and a rock mass where the host rock in the hanging wall will fracture under controlled conditions. Therefore, the infrastructure is always placed on the footwall side. Mining starts at the top of the ore body and progresses downwards in a safe sequence. It is a productive mining method where all of the ore is fragmented by blasting, and the host rock in the hanging wall of the ore body caves. Once the production drifts have been excavated and reinforced, the opening raise and long hole drilling in ring patterns are completed. Minimizing hole deviation when drilling is crucial, as it will affect the fragmentation of the blasted ore and therefore also affect the flow of the caving rock mass. Rock is loaded from the cave front after each blasted ring. In order to control dilution of waste rock in the cave, loading a predetermined extraction percentage of rock is done. Or, if there is a significant difference in density between ore and waste rock, bucket weighing can be utilized for dilution control. When loading from the cave front, it is important for the productivity to keep the roads maintained in a good condition. Dumping the ore into ore passes connected to the haulage level is an efficient way of transporting rock from the production points to the crusher. Each sublevel features a systematic layout with drifts across the ore body. Activities in the parallel production drifts are performed simultaneously in order to maintain a good process in the mine. Due to caving of waste rock into the blasted ore, a certain degree of ore loss and waste rock dilution comes with the method. Caving will sooner or later also cause subsidence on the surface. Sublevel caving is a productive large-scale mining method that enables safe and efficient use of mining equipment. With good mine planning, there are also great opportunities for automation.
In room and pillar mining, the coal seam is mined in a checkerboard style, leaving pillars of coal to support the roof, which allows for instant coal access with a relatively low invest compared to longwall mining. However, only utilizes the coal reserves between 50 and 75%. It is a mining method of its own right, as well as a supporting technology to develop roadways in order to prepare the coal face for a longwall operation. In room and pillar mining, continuity is the key to profit, from the continuous miner to the continuous flow of material. The coal is cut by a continuous miner, which delivers the product to haulers. They bring the product to feeder breaker units that prepare and deliver it onto the belt system. While feeder breakers are moved only occasionally, the other equipment is in constant motion. So maneuverability, cableless operation, and maximum load capacities are vital. With a full range of battery or diesel-powered vehicles, Caterpillar has an answer to every challenge in room and pillar mining. It all starts at the coal face with the right cutting technology. Today's continuous miners are designed to cut at highest efficiency while keeping dust levels to a minimum with water sprays and dust collectors. They are available for operations from as low as 70 centimeters up to a maximum of 5 meters. From production to the delivery point, it's just a question of volume and velocity. That's easy physics for our range of utility vehicles. Being equipped with rubber tires and an industry-leading capacity, they keep the circulation of product and material at a healthy and profitable level. The roof bolter follows production on its tail to create a safe mining environment. Driving the bolts into the roof in a safe and efficient way is most important in this real hands-on job. Therefore, ergonomic controls and easy material access are one of the most important features in our roof bolters. The Scoop's multi-purpose contoured bucket will carry equipment, serve as a multi-tool, or clean roadways and feeder sections. Extended battery life and a dual motor option make it versatile yet powerful. The Scoop has often been called the miner's Swiss Army knife, and as a matter of fact, it is a real workhorse too.